Alrighty, so this is a tutorial on how to essentially unfold your geometry, whatever it is that you get, and sort of allow you to more easily create your paper study models. And you can easily translate this into like the chipboard or the museum board that you're going to be using. It's using this program. There should be a link in the YouTube video, like the description section, called Pepakura Designer. That link will take you to what you're seeing right now, and all you need to do is download the folder. So click on this download button, then click on download a zip. It should begin to download. Let it download. I should have probably pre-downloaded this, but whatever. Alright, open it. Go ahead and either expand it out or drag it out or do whatever you need to get to open it up. So then, once you open it, go into the folder that it appears. Double click on Pepakura Designer and start installing it. It's broken up into this. There's the installer itself, the Pepakura Adobe PDF like tutorial that I pulled from Yale's website that I used to learn this, and the serial number. So go ahead and click agree, click next, click yes. You don't have to check this. I typically don't. If you do, go ahead, click next, let it install. Alrighty, check no. Then under the help section, you can go ahead and click that, then enter password and go back into that folder and open the serial file. Close this now. And just copy and paste the password in here. You have to do each section individually, otherwise it won't work. Then click OK, then OK. Alright, now it's all licensed, so you can delete this if you don't need it. Alright, so what you're going to want to do is go ahead and open up Rhino. I really should have preloaded this stuff. Whatever, I'm winging it. Okay, so go ahead and open your model that you're going to be using. If I can find mine, yeah, whatever. Thursday 6. Okay. So open it up. Notice that it's nice and pretty and done, and it's got whatever changes you need to make change to. Obviously, this is the four-sided surface one. Go ahead and, yeah, this is the 4-point. Go ahead and pick out your triangulated model. Mine is right here. I'm going to flip mine just so that the faces are where they need to be. So this is what I want to produce, essentially. So you've got to make sure that if the surfaces are not joined, make sure that they are joined. You can't have something like this, right? All these things need to be together as a whole polysurface. So just select everything, type in J or join and enter, or join, enter, right? Select the polysurfaces. If I don't screw it up. Alright, so these are all joined now. A good way to test this is to just move this geometry ever so slightly, and you'll see that I have like weird lines here. So I'm going to go ahead and you want to delete any sort of like extant data that will not be required to produce your study model, right? So that's good, that's good, that's all deleted. This is nice and clean, so I'm going to go hit File, Export Selected. I'm going to choose wherever. This one's just my desktop, right? Tutorial. Sounds good. And then make sure to, under Save As type, just choose 3ds. Hit Save. And under this option should pop up. It's basically, what it's doing is it's meshing this data, and that essentially that means that it's simplifying it and creating triangles from it. So exactly what we did with our 4-point surfaces, it's just the program is doing it for this geometry automatically. Now, that sounds like nice and convenient, but it's not, because as you'll see, like this is a preview of how it's gonna mesh. Like you get all of these weird like lines and geometries and planar surfaces. We don't want any of that, just because it's like real nasty when it unfolds, and this Pepakura program creates tabs for it. Like it's just nasty. So what you want to do is slide the slider all the way down to fewer polygons. Hit preview one more time, and now you'll see, or you'll notice that that geometry is now a lot cleaner, or at least a lot more simple. So once that's done, hit OK. Then you can close this. You no longer need it. I'm going to save it. So this is the 3ds file that we have, right, or that we exported out. So in Pepakura, go ahead and hit this Open File button. Go to wherever it is that you saved it. I saved it on my desktop. Click this tutorial, or click whatever file. Hit Open. Click OK. You'll notice that this is black face right here. Basically, it's telling you that the back faces are colored dark gray, right? So this should be okay because it's in what's called textured view. Well, I'll go over that in a little bit. So hit no flip, then hit finish, right? Then hit OK. So this is your 3D model, okay? So to eliminate this, all you have to do is unclick this button, and you'll see that the darker faces are the inside, lighter faces are the outside, right? These red edges are the naked edges, and this blue is essentially where what it's going to unroll to create. So we just got to make sure that all the geometry is fine. Yes, this looks like my model. All right. So go up here and hit the unfold button, and you'll see that it automatically unfolded this thing on a 2D surface, right? So it automatically created these folds, or these tabs, sorry, and it automatically created like fold or score lines. Now these folded or score lines, there's two different variances. One being the dash dot, the other one being just straight up dash. Dash dot is the ones folding in, so creating valleys, and the dashes are the ones folding out, so they create mountains. So this is kind of, it's a little weird, it's a little crazy. If you click on each object, it actually highlights the geometry that it's creating, right? So this little guy creates this over here, right? This little guy creates this. This big Gigantor guy creates this big Gigantor geometry right here, right? So the first thing that you're going to want to do is actually, like, oh, I don't know where, you know, what surfaces or what edges or go to which tabs. So what you want to do is go into 2D menu and hit the Show Edge ID button, and you'll see that it actually adds these IDs, or these identification marks. So this 8 tab, which is right here, goes to this 8 side, right? Let me find another example. So 2 goes to 2, 4 goes to 4, right? All this stuff. Nice and pretty. It's not, I mean, you'll find that sometimes when it creates these tabs, it's not like 100% clean, but keep in mind that this geometry, they are tabs, so they'll work. Like when you cut this out on your mat, like you're basically gonna be cutting here, here, then here, and here, right? This will create the geometry. This will create the tab. You're never gonna see this, so it's fine that this little bit of portion is just completely cut off, because you're going to put glue on here, and it's going to glue to side 27, which is like off somewhere. I don't know, anywhere around here. So just keep that in mind when you're cutting these out using your X-Acto, that it's going to look weird, but it'll unroll just fine. And in fact, I've already done 3 of these, and using this method, and it unrolls. It essentially starts unrolling itself, and it starts making itself while you're unrolling it. So it's just a whole lot easier to go through this stuff, right? So another thing that you want to keep in mind is you got to know like the height of the basic height of your model in millimeters, right? So I forgot the conversion. Let me see. Right. So for every 1 inch, it's 25.4 millimeters, right? So if this is like 4 inches tall, it's roughly 100 millimeters, right? Because in order to get scale correctly, so let's say this is 4 inches, like from here to here, that's 4 inches, and that's what I want to get out of my model. And we'll do scale next. So go to 2D settings and hit change scale. then scale factor, and it's going to ask you for the height. That's all we're concerned with, just the height. So I know that my model is 4 inches tall, so that's going to translate to roughly 100 inches, or 100 millimeters, sorry. So hit OK, and you'll see that it automatically scaled this by what I've set it to, or by the factor that I've set it to, right? And you'll also notice that it expanded the amount of sheets of paper that are available. I think this is 8.5 by 11. Right, so we're going to have to change the paper size, obviously. So next up is changing that paper size. So we go to File, Print and Paper Settings. Actually, that was an A4. A4, these are all, this entire program is like in metric. So A4, A3, A2, and A1s are actually metric measurements for paper sizes. So like they're European measurements. So this looks like it's going to be roughly an A2. So just set the paper size to A2. Make sure that print lines clearly vector print is set, or you've checked off, as opposed to print lines smoothly. You want them clearly. And then line weights, I set them at around 8. I think that's a good overall size, because that's the line weights of the of what's showing right here. So they'll read a whole lot better when you print them all out. So then hit OK, and you'll see that that was roughly that was a pretty good guesstimation of how large this thing is going to be. Now you'll also notice that there are margins. It's good to stay within the boundaries of these margins. So my model, or my unroll, obviously does not. So a way to rotate is, all you need to do is right click, hit rotate, and then, well, just click on it and start moving. Right, so I'm going to move this way. So then again, it's clicking on one of the vertices and then clicking somewhere else and then start rotating it. And then just start positioning these guys such that, you know, they lie within the paper size itself. So that's fairly convenient for me. Oh, here's another thing. Zooming in and out is inverted, so let's go ahead and change that. Go to Settings, Other Settings, Others, and then reverse zoom direction. And while we're here, go ahead and place Edge ID inside of Face, and then choose the font size, and set that to 8. All right, that should be it. Yes, and then hit OK. So what we just did, the font size changes the font of the tab and sizes, right? Or the tab font sizes right here. So this just got bigger is all. Which it'll help us when we're reading these cutouts and trying to put it all together. Okay, so that is all done. We can right click, hit select and move. And now, say, like, this is going to be a big guy to cut out and like work with. It's going to be really frustrating to start working with this thing. Or not frustrating, but it's going to be slightly more difficult to work with it. So I want to, like, say I want to split this guy up into 3 pieces, because it seems like it inherently wants to be 3 pieces. So an easy way to do that is you simply right click, join and disjoin face. Now you'll start seeing, like, if you highlight over an edge, it basically tells you where that edge meets up with. This is a really good tool when you're starting to put it back together. So see 2 meets with 2, 38 meets with 30, or 39 meets with 39, 38 meets with 38, 15 with 15. You guys know numbers. Okay. So I'm going to say I want to split it here. So it splits that, creates a tab for it. And I'm going to split it here. It splits that and creates a tab for it. Done. That's it. That's where I want to split it. You can split it further, or, you know, in a more meaningful way to what you're doing. Like, I could go further and do that, right? So it's just how you're going to want to fabricate this. It's easier to work with sort of medium-sized chunks than it is to work with larger-sized chunks. But I wouldn't go so far as to create these tiny, tiny chunks for me to put together. And in fact, I think this is kind of too small for me to work with, so I'm going to click on here, and it's going to try to find a way to match these up in a meaningful way. But, like, again, like, it does, like, weird stuff like this, so I'm going to just disjoin it, and I guess just leave it there, because there's no easy way to put that there. So the software did its best to put that in a meaningful way, so I'm just going to leave it. I'm just going to look around my model, see everything's fine. This is kind of odd, but screw it. Oh, no, that's fine, I guess. You know what, in fact, let me, nah, I'll just leave it. All right, whatever. It is what it is. Okay, so this is now, since I'm saying that my model is 4 inches in height, this is now a 1-to-1 model, right? So if this was in your 3D model, if this was like an 8-inch height, this would be a 1-to-2 size model. So keep that in mind. Scale is always a big important factor when creating these models, obviously. Okay, so we are done with that. All we need to do is create a PDF. I'm just going to move these guys down a little to be slightly more proportional. Okay, so all we're concerned with at this point in time is to create a PDF, right? So go to File, Printer Setup, and then just make sure to change this to Adobe PDF, and then change the size to the size that we set it here. Remember, we set it to A2, or whatever it is that you've set it to. So right now, in this example, it's A2. Then hit OK. That's it. Then what I would do is I would save this file. It's going to save as a .pdo file. Save it to the same location that your 3ds file is at, which should be the same location that your Rhino file is at, or the original Rhino file is at. Hit save, and you'll notice that you have this guy right here. So you can go back. All the work that you've done is now saved. So hit File, Print, go ahead and choose Adobe PDF, hit OK. The dialog box should pop up. Go ahead and save it to the original spot or any spot that you want to. It'll create that PDF, and this is it, right? So all you've got to do is take this to the plotter upstairs and plot it out. It's at A2, so it's rather small. This would technically be a half size for my actual model, because my actual model is 8 feet or 8 inches in height. So, I mean, quick things to remember to recap everything. These guys, the solid lines are cuts, dashed lines or hidden lines, I should say. They are mountains, so they fold in, or they fold out. And these, where is one? Dash dots, those are valleys, so they fold out, okay? So I find this a whole lot easier when constructing my stuff, just because like I don't have to remember what folds in, what folds out. The line work tells me itself, and I actually like the way the line work reads once the model's done. So hopefully this should sort of accelerate your model making towards the point where you can start creating more and more study models for more and more iterations, and like, you know, it alleviates your concern that, oh crap, I need to make another model and that's going to take me 4 hours. Literally, when I did it, and when Joe and Izzy did the same method, it took them like maybe 30-45 minutes per model, and like that was because that was our first time doing it. I do not doubt that we can start getting this down to like maybe 15 to 30 minutes per model, which is insanely quick, so that you can start seeing like the changes that you've done, the changes reflected in something physical that you can hold, and seeing how that impacts your overall design. So that's it. I'm going to tend to try to do more of these tutorials if there's more of a need for them. I know I'm really shitty at doing them just because I'm talking to a computer right now, and I feel like an asshole, but I'll do them. And I'm just like muttering right now, but just let me know if there's like, if you have any questions, post them on the YouTube thing, or on the better yet, post them on the Facebook thing, or on the Facebook posts that will link to this YouTube video, just so that I can more easily answer them, or more easily get to them. I know it's kind of late. I promised some people that I'd post this today. As I'm doing this, it just reached tomorrow, so I guess my promise is broken, but whatever, you have something. Okay, that's it.